This section is going to cover a really powerful aspect of natural language processing, and that's classifying text using your own custom labels to create a custom classifier. This is a supervised machine learning problem using different classification algorithms. The algorithms we'll be using for the lessons in this section are logistic regression, naive Bayes, and linear support vector machine. We won't be covering in too much detail how these algorithms work. We'll just be using them for text data. But if you're interested in learning more about these algorithms or how to tune specific hyperparameters, I can definitely recommend checking out the relevant courses on the 365 Data Science platform. For now, let's get started building our own custom text classifier using logistic regression. Let's first start by creating a logistic regression model to classify our text. This is a great model to use either as a standalone model or as a baseline model before you move on to any more complex models. We'll start by importing the packages we need, so we'll be importing the pandas package and the sklearn package. Because the sklearn package is quite large, we won't be importing all of it. Instead, we'll just be importing the selected functions that we need. So for this exercise, we'll be using a sample data set of sentences and their associated sentiment. We're looking to create an algorithm that can classify the sentence by the sentiment score. As we saw in our earlier lessons, there's various ways of computing sentiment already out there, but sometimes the accuracy just isn't enough, or you may have data that's not quite suited to the algorithms that are already out there, and you want to build your own custom model. In these next few lessons, we'll be seeing how we can do this. We've got our data set and we've got two columns. We've named them text and sentiment. The next step is just to shuffle the data to ensure we've got a nice mix of positive and negative sentiment sentences throughout the text. We'll be using data.sample with the fraction set to 1. This will just shuffle our data for us. We then want to reset the index. We'll then create our x and y to feed into the algorithm. Our x is our data text column and our y our data sentiment. We then want to do our text vectorization, and we'll be using the bag of words here using the count vectorizer function. Of course, you can also experiment with things we've covered earlier in the course, such as TF-IDF vectorization. So we'll initialize our count vectorizer and call it countVec, and then create countVec_fit and run countVec.fitTransform on our X data. We'll then create our bag of words and convert it into a pandas data frame. The column names come from countVec.getFeatureNamesOut. We can then print this bag of words to see what our data looks like. We can see each of the rows is an individual sentence in our data and each of the columns an individual word. We then want to create our train and test data for our algorithm. So we create xtrain, xtest, ytrain, and ytest. We can then use the train test split function from sklearn to split our bag of words and our y into our training and test dataset. We specify the test size to be 0.3, so 30% of our data is going to be set aside for the test data. Let's now create the logistic regression model. We'll call it LR, and then use a logistic regression function. Again, we specify our random state, and then we use .fit on xtrain and ytrain. We can then predict this against our test dataset. So we create ypred_lr and then use lr.predict on our x test that we've set aside. From this, we can then use it to compute the accuracy score using the sklearn function accuracy score. So we can look at the accuracy between our ypred_lr and our ytest. We can see here the accuracy is incredibly low, so our model has not performed well at all. However, like I said, this is a really good baseline model to use before you move on to anything more complex. So this is a good baseline for us to definitely try and improve on this. We can then use the classification report and put in our test data and our predicted data to see how our algorithm works at predicting different types of tags. Let's now see if we can prove on this logistic regression with some more complex models. Let's try and improve on that low accuracy score using the naive Bayes model. We'll want to import this from the sklearn package using sklearn.naivebayes import multinomial NB. We can then create our algorithm and call it NB. We then use the function multinomial NB with empty brackets. We then use .fit and input our xtrain and ytrain. We then create our predictions on our test dataset just using the predict function from sklearn and use this to compute our accuracy score. So we compute the accuracy on our ypred NB and test it against our ytest for our accuracy. We can see here the accuracy has improved a little bit, it's 0.33. So it is an improvement from our logistic regression model, but it's still not worked that well. Let's take a look at the classification report. So we'll run classification underscore report on our ytest and our ypred NB and print this out. The naive Bayes model is improving a little bit as it's using both positive and negative classifications. However, there is one more model we can try to see if we can push this accuracy a little bit further. The final algorithm we're going to try is a linear support vector machine. This has been shown to work really well with text data, so let's see how well it can classify our simple sentiment dataset. The first thing we need to do is obviously import the packages we need for this. So from sklearn.linearModel, we're going to be importing the SGD classifier. There are a few packages that can run this algorithm, but this is the one we're going to use for this lesson. So if you are looking through other documentation and other tutorials, you might see them use a different function, but what's going on is basically the same under the hood. We then want to create our model and fit it to our training data. So we create our SVM and then use the SGD classifier function. This function can be used to run a few different arguments. However, the default arguments will give us the linear support vector machine that we want. Feel free to check out the documentation on this function for more information. We then use .fit and fit the model to our X training dataset and our Y training dataset. We then create our predictions and we'll put these into ypred SVM. We then use svm.predict on our xtest dataset. Let's now calculate the accuracy score and see if we've improved from other models that we've used previously in these lessons. We're getting an accuracy score of 0.5, which is an improvement on previous models we've used, but honestly this result still isn't that great, so we might need to go back and think about our data and cleaning this up, maybe adding some more data in there to try and improve that accuracy score. However, this is just what happens in machine learning projects. You don't always get the best outcome first try. You do need to run the models, see what they look like, and then perhaps go back to your data, go back to your problem, and think about any changes you need to make more upstream in your workflow in order to increase that accuracy. In our next lessons, we'll be covering a full practical example where we'll come back to these algorithms again and try them out on a different data set.